Division of a factorial by another number. This is what we are going to learn in this class. Now, just as a recap, we can write 10 factorial as 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Again, the 10 is broken up as 5 into 2, 9 is 3 square, 8 is 2 cube, 7, 6 is 3 into 2, 5, 4 is 2 square, then we get 3 and 2. So we add up and we get the final answer as 10 factorial can be written as 2 to the power 8 into 3 to the power 4 into 5 square into 7 to the power 1. Since 10 factorial is a relatively small number, we have done this process manually. But what if we want to do this process for a very large number? That we will see how to do it in a shorter and faster way. So what we do is, when we have to divide 10 factorial into its prime factors, we keep dividing the number and we get the same result as we got just now. Divide 10 by 2, you get 5. Disregard the remainder. 5 divided by 2, you get 2. Again 2 divided by 2, you get 1. Then you add all the quotients obtained and you get 2 to the power 1 plus 2 plus 5, that is 2 to the power 8. This 2 to the power 8 matches with 2 to the power 8 that we got here when we did the same process manually. Again, for powers of 3, we divide 10 by 3, we get 3, forget the remainder. Again 3 divided by 3, we get 1. So total number of 3's in 10 factorial is 3 to the power 1 plus 3, that is 3 to the power 4. That again matches with the result we obtained manually, that is 3 to the power 4. We repeat the process with 5 and 7 and we get 5 square and 7 to the power 1, which you can see is matching with the same figures written in blue above, which was done manually. Obviously, we are not using the terms 4, 6, 8 because these are not prime. Since these are not prime, so these are already included in the 2's and 3's. Number of 6's is included in 2's and 3's. Number of 10's is included in 2's and 5's, and so on. So we come to a very basic question. How many zeros are there at the end of 100 factorial? This is a sum which has perplexed many of you when you initially started preparing for CAT. Well, we all know that any factorial number can be divided into its prime factors. So 100 factorial can be divided as 2 to the power A, 3 to the power B, 5 to the power C, 7 to the power D, and so on till 97 to the power something. Since we are looking for number of zeros at the end of 100 factorial, obviously we will look at the factors of 10. Factors of 10 are 2 and 5. So we just need to know how many 2's are there in 100 factorial and how many 5's are there in 100 factorial. So we'll repeat the earlier process. 100 factorial divide by 2, 50. 50 divided by 2, 25. 25 divided by 2. So you get all the quotients from 50, 25, 12, 6, 3 and 1. Add them up and you get number of 2's in 100 factorial is 97. Similarly, we do it for 5. Number of 5's in 100 factorial you get by dividing 100 by 5, quotient is 20. 20 divided by 5, quotient is 4. So number of 5's in 100 factorial is 24. Since we are looking at number of 10's or number of zeros at the end of 100 factorial, we are only concerned with number of 2's and number of 5's. So let us see. 10 equal to 2 into 5. Let us consider 2 as a jalebi and 5 as a samosa. So if you have got 97 jalebis now, which is 2 to the power 97, and you have got 24 samosas, which is 5 to the power 24. Each person eats one jalebi and one samosa. Otherwise, he cannot eat. So, how many people can you feed? That is the basic question. So, what we see is in 100 factorial, there are 97 twos and 24 fives. So, the constraint is 5. Hence, only 24 people will be able to eat one jalebi and one samosa. That means number of zeros at the end of 100 factorial will be 24. What happens if instead of 10, we have to divide 100 factorial by 20? Again, you break up 20 into its prime factors, which is 2 square into 5. So now one person wants to eat 2 jalebis because there are 2 twos. So I want 2 jalebis and 1 samosa. Then how many people can I feed in 100 factorial? Divide 97 by 2. So I can eat 48 people 2 jalebis each. And I can feed 24 people 1 samosa each. Again, the constraint is the 5 or the samosa. So I can have 100 factorial divided by 20, 24 times. Same as above because the constraint remains 5. What about if I have to divide 100 factorial by 80? Like before, 80 can be written as 2 to the power 4 into 5 to the power 1. That is, now a person wants to eat 4 jalebis and 1 samosa. So, since I have got 97 jalebis, I can feed 24 people. I have got 24 samosas, I can feed 24 people. So, the constraints are equal. I can still divide 100 factorial by 80 24 times. Let us go one step beyond this. What about dividing 100 factorial by 160? Now 160 is 2 to the power 5 into 5 to the power 1. So one guy wants to eat 5 jalebis and 1 samosa. So how many people can I feed if I have 97 jalebis? Only 19. And how many people can I feed if I have 24 samosas? I can feed 24 people. But then some people get only samosas, which is not acceptable. So now my constraint is number of twos. So how many times 100 factorial can be divided by 160? The answer will be 19. Hope the concept is clear. If not, please review the recording once more. Thank you so much.